Welcome back to TalkitDoit. In today's video, I'll walk you through how to use Open Policy Agent to help safeguard your key infrastructure, which can be on any cloud. Today, I will use Azure. The tools needed for this are Open Policy Agent, Terraform, Slack. We will also use GitHub Actions. And lastly, we will make use of a GPG key. All the code and instructions will be available in the repository linked in the description below. Let's start looking at the sequence that we will implement to give you a quick overview of the flow. Starts with a pull request, which then triggers a GitHub Actions pipeline, which runs a Terraform plan and a policy check is engaged. If a protected resource, a Slack message is sent as we need an additional approval, and once approved, it will then run the infrastructure update. This is a simple example, and you would add smarter logic before mainlining and applying. All of this will be in the README in the repository, which is linked in the description below, and we'll have links to installing the tools used. Now let's look at the code, starting with the HCL, where we are using a resource group, a virtual network and some subnets. Notice the tags? These are what we are using for our policy checks, which require an action based on the values. Now the policy code, which is REGO, notice the tags logic here? And a quick look at more of the policy logic. This helps support our policy checking in the pipeline. We check for specific exit codes, such as when Terraform determines it needs to destroy a resource as part of the plan. And a real quick look at the YAML code for our GitHub Actions pipeline. You can see we are capturing the pull request number and also providing things like Slack webhook details. You can see our Slack channel is empty. This is where we will send the message if the policy finds a resource to be deleted. Full code is in the repository, which is linked in the description below. CODEOWNERS. This is important, and we will use a CODEOWNERS file to allow us to define specific teams or users that we want to review our code. This helps us to automate our code approvals, and when used with requiring CODEOWNERS to review our code, this provides a great improvement to our code governance. In our example, we will use the infrastructure approvers team to make sure our Terraform code is reviewed by Bribe Binary, who is a member of infrastructure approvers. Now let's make a change to a protected resource, commit the code and watch the pipeline run and see the policy as code in action. Let's create a new branch where we will make our changes for the pull request and then look for our Slack message. Here, we will add a -YouTube to the name of our resource group, which has already been deployed. As this resource has the correct tags and values, Open Policy Agent policy code should pick this up and require an approval. We can now push our code change. Let's create the pull request from the code we just pushed. Do you notice the required approvers? This is from our CODEOWNERS file. Let's push the Create Pull Request button now. We have branch protections and also require code owners to review our pull request, so you can see that merging is blocked. I prefer to sign my commits using a verified key and set my GitHub to only allow commits that are verified. Instructions are in the README file. We do not have to do this on every branch. For this pull request, as we require code owners to review, I have switched to the user mentioned earlier that is part of the infrastructure approvers team. We can review the code and approve if it looks good. So let's approve this change now. We can see the policy has detected a protected resource and sent a message to our channel. Powerful when used with the GitHub conditions we set. Now let's switch back to the original user so we can check all approvals and protection conditions have been met, so we can look to merge our code changes. This looks good, so let's merge and apply these changes to our infrastructure. You can add smarter testing logic, and you should, but for this simple demo, we will just go to the deployment phase of this sequence. Here you can see the name of the resource group that is currently deployed. Let's merge our code change to start the pipeline. We can delete our short-lived feature branch, as we will not need this anymore, and no need to keep it around. We can see that our GitHub Actions has started. Notice the previous feature branch pipeline run, which is where our Open Policy Agent logic caught the protected tags. And now we see our merge now running this apply pipeline. For speed of this demo, the pipeline run length has been shortened, and I will not show all tasks. Do clone the code and use yourself to see each task and its output. Notice our resource group is being destroyed. This is expected as we have made a destructive change to the resource name, which highlights a good use case as to why using Open Policy Agent can really help improve our destructive infrastructure changes that is now completed and we get a passing pipeline run, but we need to make sure the resource has been recreated and that the resources within this resource group have also been recreated with the original settings we had in the code. We can refresh and check the name change has been applied, and it has. Brilliant. Remember, we had already deployed a virtual network and subnets in this resource group, and we can check to make sure these have the correct settings, as they had to be redeployed as part of recreating the resource group. And all the settings are the same. Again, that is brilliant, and exactly what we want to see. Now, to finish this quick demo, let's check out back to our main branch and pull the latest from the repo so that we are up to date and ready to work on the next cool feature. We can see our main.tf file, which had our code change, so we now have that in our local main branch. And there we go. All done. This was only a quick demo to show a specific use case of using Open Policy Agent. Open Policy Agent is a great tool and has many use cases. The REGO code itself is portable and declarative and can be used for policy requirements on many things and can be used across different cloud providers. All the code and instructions can be found in my GitHub repository, which I've linked in the description below. Please check it out and let me know what you have done with it, as I would be really interested. Thank you for watching. I really appreciate your time. And if you found this useful, a subscription and a like would be great. Have a wonderful day.